Hello everybody, this is Itsu. I'm still struggling kind of with my VCO, voltage controlled oscillator with the TL494. I got a lot of suggestions and advices from user Verpes and Vortex about my circuit. So I tried to incorporate all those advices. I built, instead of a breadboard, I used a experimental board setup, and I put my MOSFETs together on one heatsink, and I also got a nice, I think that user Hoppy also is correct that the toroid being used is a commercial one, like a small one, 220 volt or 115 volt to 12 or 9 volt, and small size. So that also eliminates the problems with the driving the MOSFETs, because of the low amps of the 2 or 3 or 5 or 7 turns. So I also had this toroid. I have another one on order, a smaller one. This is a 100 volt amp toroid, 220 volts in and 2 times 10 volts out. So I turned it around, and basically I let both MOSFETs now drive the secondary side 10 volts. And at the moment I have the 220 volt side open, and I have a resistor there for measuring, testing. I basically use this circuit here, the TL494, which works kind of good. And then I made this push-pull configuration. I used this in between stage as well. I used 2 times 2 N4501 4501 instead of the BC55H here, because that's the one I had. And the rest of the circuit is basically the same. I only have the IRF740 MOSFETs. I have a 0.47 ohm current resistor in the source lead, so I can measure the voltage and therefore the current in both legs. And as I had a lot of high voltage spikes, also explained by Verpes, I put a Zener diode across the drain and the source. I had a 12 volt Zener first, but one side blew out all the time, so it's getting very hot. So I now have a combination of a 12 volt and a 5.1 volt, so basically 17 volt Zeners in both sides. And that goes to this side of the toroid. And the circuit kind of look like this. I have here the both Zeners. Not sure if you can see it. Close to the MOSFETs. These are the current resisting measurement resistors. They're getting kind of hot because I'm pulling 7 amps or something still. But I think this 17 volt Zeners also get very hot still, so I'm not sure if this is the good solution. Perhaps I can get some advice. I made some current scope shots. I put it on hold at the moment. I put my probes on across the both resistors of the both drain sources resistors, and I overlapped the both traces. So this is the resulting signal, and I think I can see a very steady build-up of the current on both cycles. I have almost no dead time, and we are at 2 volts per division, and we are measuring 3 volts. So this is as the resistors are 0.47 ohms. It's something like double this, so it must be 7 amps almost. And this is what I measure. I can expand it a little bit. This is how it looks like. Not sure. I do not see any spikes anymore. There was a lot of spiking there at the end. So I kind of like this signal. Only problem is that I don't think it's stable enough, because I'm getting the Zeners are getting very hot. Okay, I will try to make some other measurements, like the gate signal and the output on the toroid, and then I can then you have the complete picture of this. The difference in the output here is a little bit, I think, the resistors being used. One is less ohms than the other one, so I think that is the reason why I have different values there between one. Peak to peak channel 1 is 3.4 and the other one 3.7. But I measured a slight difference of a few tenths of an ohmage. Okay, I will try to make some other measurements now. Okay, next measurement I did was I had the red probe still on the output across the drain source resistor, and I have the yellow probe on the gate, probing the gate signal. And you can see the output in the red probe the same as before, the current. And below we have the gate signal of the same MOSFET. We are still at 4.6 kilohertz, the frequency set, but the gate signal is 12.2 volts, 45% duty cycle. And I guess it's kind of squarish stable. We have something here on top at the first. We are at 5 microsecond per division. 5 microsecond glitch there. So this is the gate signal. Next I will make some output signal trace. Okay, now I have the red probe still on the current resistor in the source, and I have the yellow probe on the drain of the MOSFET. So we see here the voltage, it's set to 10 volt per division. I have peak to peak 31 volts, so not sure how to interpret this, but we can see that if we pull current, that the voltage is dropped till about 8 volts. After that we have, when it shuts down the MOSFET, we have some spikes and going back to 12 volts again for some time. Not sure where the first two spikes come from, perhaps because the other MOSFET is turning off at that moment and of turning on. Okay, I will try to make now a let me expand this one a little bit. This is how it goes when it shuts down, and this signal appears when the MOSFET gets turned on. Okay, I will try to make a scope shot of the both drains of the MOSFET, see if those peaks are coming from where I think they're coming from. Okay, this is both MOSFET's drain voltage, both peaking 30 volts. And yeah, I guess this is not ideal yet. Somehow these peaks don't need to be there, I guess. But it's kind of flip-flopping between 8 volt and 12 volts. Okay, we'll measure now both gate signals. Okay, these are the gate signals. We are at 15 microsecond, 5 volt per division. And we have 12 volts something. Try to see if I can zoom in a little bit. We have some signals there being bumped up, and not that much, but okay. Make some measurement on the output coil now. Okay, I have the red probe now hooked up across a resistor, 55 ohm, 10 watts, 55 kilo ohm, sorry, 10 watts, and I have the yellow probe across one of the MOSFET's source current resistor, and this is the output. Below you can see the yellow trace is the current to one of the MOSFETs, and the red trace is the output across the 55 kilo ohm resistor. Looks like a lot, 129 volts, but there's a lot of spike and peaks. Basically I have a square wave, we are at 20 volts per division, so we have a square wave of plus minus 20 volts, or 18 volts rather, with a lot of spiking. So I'm not sure, it's strange, because normally we should have much more voltage here, because we step up from 12 to 20 or something. I'm not sure, perhaps I have to swap over one of the leads that we are now in kind of bucking mode, clockwise, counterclockwise. I have to check that. Okay, this is the signal with two of the yellow leads swapped over, but it's getting worse. I guess I'm now in bucking mode, because now the signal is almost cancelling each other except for the transition time. So this is definitely not the good configuration of these input coils. I have to move them around. But that begs the question why I have this low voltage in the picture before. I have to make some measurements on the toroid, perhaps something is damaged. Okay, although I cannot measure anything wrong with it, I measured ohm value about 0.3 ohms between the yellow and between the blue, and 7 microhenry inductance, and on the 220 volt side I measure about 14 ohms and 300 microhenry, and there's no short between the primary and secondary, but when I put 220 volts on it, it started to get very hot and warm, and it starts shrinking the plastic. So there is something wrong in this toroid inside. So I have to try to dismantle it to see what's wrong, but that will be the reason of this strange output measurement I had later on. Okay, well, I think that was all for now. I have to get back to the current measurements when I have a good toroid. But perhaps someone can react on the measurements and the scope traces seen, if this is acceptable, or that I should have try so better to get these spikes on the voltage, the drain voltage away, and not sure how, but we are going slowly, but we're making some progress. Okay, thank you for watching all.